going to change gears here. I've been tasked this morning with running us all through the what's going to seem like a never-ending list of invasive native look-alike pairs. But before we get too far down that rabbit hole, I wanted to start off just taking a few minutes to think sort of philosophically about how we recognize plants. How do we actually determine plant species? And the reason I want to do this is really because people on this call, people in this field, they come to it really from a variety of backgrounds that may or may not include any formal botany training. And for some of us that are really old, we might have forgotten most of what we learned in college anyway. But really, there's plenty of people out here with no formal training who are excellent at plant ID. They're highly observant, great memories, and so they might be able to recognize lots and lots of species. And really, regardless of what your background is, you're probably, when you're out in the field, you're just relying on some overall similarity to recognize a plant in the field, right? And this is what I like to think of as the gestalt, right? It's the gestalt of that plant. It's the whole of its appearance is greater than the sum of its parts. So, you know, when I'm out in the field, I might look at a shrub and I might go, oh, I think that's a blueberry. Looks like a blueberry. And what's happening there, of course, is that my brain is processing lots of little details about that plant. And, you know, it's like a magic 8-ball or something. It's just shaking all of that up. And what floats to the top of my brain is, oh, it's probably a blueberry. So, you know, we're really good at doing this. And usually it works. But we're going to be going through a bunch of situations today where maybe it doesn't work. And maybe you end up spraying a native species because it looks so much like an invasive species. So we don't want to end up treating the wrong plant. And really, there's a few take-home messages here. The first is really that we want to move past that gestalt, to be thinking about specific characteristics so that you can be really certain of your identification in the field. The other thing we want to be doing with this is really raising awareness of there's many native species out there, even rare species in Florida, that can resemble invasive species. And we just want to be aware of that, thinking about the specific characteristics to tell those things apart. So what we're going to do right here is just run through some basic terminology. This is stuff you've probably had in college if you've had formal training before. It's just general terminology, what I call Botany 101, right? So if you've had a field botany course, you've had a plant systematics course, you've probably covered all of this before. Or maybe you just need a little refresher. So I'm just going to run through this so we're all kind of on the same page about these different terms that we're using. Again, I'm not really, you know, wanting everybody to be able to walk away and be able to rattle off all of these terms, but I want us to be thinking about these specific little characteristics that we need to use to identify plants. So all of this terminology is really can be very useful to you. Certainly, if you are going to be brave enough and you have an unknown plant to sit down and try to go into the Wonderland Guide to the Vascular Plants of Florida, right? Because you open that up and you're really going to have to know what you're looking at here, right? There's just so much terminology going on. And really, if you are trying to identify a plant from scratch, this is a terrible place to start because If you don't already know the general group that you're looking at, the family, this is going to be very, very difficult to do. And so most of us, even people who are trained in botany, will often resort instead to using a picture book. Picture books are great because they allow us to go through, right? We can flip through quickly. Maybe I found this plant out there and I don't know what it is. I can flip through and, oh, wow, here's 3 plants that really look very similar to it, right? I'm getting the same general feel. All 3 of these look like that. But this is the point at which you really need to be thinking about these smaller characteristics, right? Start thinking about how to look at this plant piecemeal. And something that you'll notice in all of these is that even though they have this similar spike of flowers that are white, if you looked at the margin of this leaf and you were observant to notice that this has a serrate margin, there's teeth along the margin, and then you were to look at this picture book and you would look specifically for that characteristic, you would notice that only the clethra matches that description. So this is what I mean, right? You can rely on that overall similarity only up to a point. And then you want to be thinking about specific little characteristics that will help you to make a definitive identification. And of course, this terminology is also really useful if you were trying to describe this plant to a knowledgeable person. If you were sending somebody a picture, pictures are great, but if you're sending this to a botanist, they will likely have other questions about that plant, and you want to be able to describe it to the best of your ability. So this kind of terminology will also help with that. You've got a handout, which is these vegetative characters and reproductive characters. So you can follow along on that if you want.
Hey, Kim, I'm just going to butt in for a second.
Yeah.
Most folks have those handouts, but any of those who registered like right before the workshop, they don't have them. But most people do though.
Okay, and we can send those out if you don't have them. We can send them out later. So what I want people to think about as they're looking at a plant is just to be thinking about all of these different characteristics. We're going to focus on vegetative characters, and the reason for this is that, as you know, when you're out in the field, maybe you've got some flowers and fruits, but often, no, you're having to rely on just leaves, and maybe that's all you've got. So, you want to be able to look at these things very carefully. And I just want to very briefly talk about this. Again, I know that many of you have had formal botany classes, but I just want to remind us all about the architecture of a typical plant, right? A typical dicot. So plants, as they're growing and attaining height, they're attaining height from this terminal bud. They are growing at this terminal bud. So you've got a stem, terminal bud on the end, and then along that stem, at a location called the node, you'll have the production of a leaf. That leaf, and where the stalk comes off, will form an angle, which is called the axil. This space between the stalk of the leaf and the stem is called the axil. And within that, you'll have an axillary bud being formed. Dexter, can you actually see my cursor as it's moving around?
Yeah, we can see it.
Okay, thank you. Sorry, I don't do a lot of Zoom, so I don't know what people can see or not. Thank you. Okay, so we have a leaf being produced. The angle between the leaf and the stem is called the axil, and you have an axillary bud that's produced just above the leaf. You always have to remember this as the basic structure, right? The stalk to that leaf is often called a petiole. And then the space in between those nodes is called the internode. So one of the first things you really want to pay attention to on a plant is how are the leaves arranged? Are they alternate, opposite, whorled? The way to do that, again, is to know about that axillary bud, to be looking for it. So with an alternate arrangement, you have a single leaf that's produced. And we can tell that there's a single leaf here. Here's the axillary bud. That's the node. So only one leaf is being produced per node, as opposed to an opposite arrangement in which we have two leaves being produced at each node. Again, if we were to look closely, we would see those little axillary buds.
Good. Linda, right? Yeah. Good. Got it. All right. Good to see you there.
Whoops. And then there's also a situation called a whorled leaf, where you have more than two leaves being produced. You have to be careful with this term, because sometimes you can have plants that have alternate leaves that just become very, very clustered up at the end of the branch. They can appear to be whorled, but you have to look and make absolutely certain that you've got three leaves coming off at exactly the same point on the stem for it to truly be a whorled arrangement. And then the second thing you want to be paying attention to is whether or not the leaf is divided. So if it's divided, of course, then we call this a leaflet. The way that we know that this is a divided leaf as opposed to a plant with opposite leaves is to look again for the axillary bud. So I can see that axillary bud right there. So I know that this is a single leaf and it must be divided. So in this case, it's a pinnately divided leaf, and they're alternately arranged. So I can see here along the stem, there's only one leaf per node. So you can have simple leaves with only a single leaf blade per leaf, or you can have something that's pinnately compound or in the shape of a comb, or it might be palmately compound, where the leaves are coming off kind of like your fingers off of the palm of your hand. If that compound leaf only has three leaflets, then it's called trifoliate. So that's where we have that leaves of three, let it be, which I wish I'd learned as a kid, because I got massive amounts of poison ivy when I was a kid, and now I'm deathly allergic to it. And we can also have leaves that are more than once compound. So in this case, if we were to look here, we would see an axillary bud being produced right where that leaf comes off. So we know this is a single leaf. And then that leaf is divided along this axis here, and then divided again along a second axis. So it's bipinnately compound or twice pinnately compound. You also want to pay attention to the leaf shape. Is it widest above the middle, at the middle, below? Is the leaf more linear? Look at the leaf apex to determine whether or not you've got an acute or like a less than 90-degree angle being formed, obtuse. Maybe the leaf apex is sort of gradually narrowed into a long point, which is acuminate, or it's notched. There's a variety of terms we can use to describe the leaf apex. Many of those are the same for the leaf base, but we also have terms like cordate. So if you look at the base of the leaf, if it's heart-shaped, it's what we call cordate. And then very importantly, you want to note if a leaf is asymmetrical or oblique at the leaf base. This is an important feature of elms. So as soon as you look at this leaf and you see it's got serrate margins and oblique leaf base, you should immediately be thinking, this is an elm tree. So some of those can be really important features. So that leaf margin, you want to note if there's any teeth, like we saw in our example earlier with the clethra. noting that it had teeth there immediately told us that it was clethra and not tie-tie or black tie-tie. Sometimes those teeth can be really minute. You want to just run your finger along the margin and see if there are any teeth that you can barely see. The teeth might be sort of a different shape, as we have with this dentate margin. You get Viburnum dentatum, a very aptly named species. The leaf margin might be turned under, sort of rolled under, or lobed or entire. Again, a whole range of terms here. Sometimes the venation of the leaf is very important. So it can be pinnate, again, shaped like a comb, or the veins might be palmately arranged, like that. Those veins might diverge and end in the lobes of the leaf, or they might, as in this air potato, those veins, you notice they're all curving back and ending up at the tip of the leaf, coming back together, converging. So in addition to all these features about the leaves, about the margin, about the shape of the leaf, the arrangement, the division, you want to note on a plant any other interesting features. So it might have glands, which can be highly diagnostic. So these might take the form of pellucid dots that are embedded in the leaf blade. So to see that, you'd have to like hold this leaf up to the light. You could see all of those little dots in there. Or you might have glands that are on stalks, like you see in sundews. You want to notice any hairs that are on the plant. So the distribution, the shape of the hairs, whether they're stellate, that's all very important information. Often you'll need a hand lens to actually see some of this, look at it under magnification. Or they might have some really interesting features like scales on the underside of the leaf, as we have in this croton. It's very interesting. So this would be an important feature. Something I always stress to people is to look for milky sap. As soon as you see milky sap on a plant, you know there's just a few plant families that have this feature. So you just break a leaf off, as they've done. So this is the non-native Asclepias. So they've broken a leaf off here, and you can see this copious milky sap just pour out of it. Other important features are whether or not the stem is armed or unarmed. So if it's armed, of course, it's going to be prickly in some way. Those sharp, pointed features can either be, they can be developed from a axillary bud here, which is where we got this thorn. Thorns are just modified branches. So here we have a thorn. We can tell that it's a branch because it's coming out above the leaf, right? So there's our node, the leaf was produced, and we've got a thorn above it from that modified branch. So here we have in Gleditsia doing exactly that. We can also have spines, which are modified leaves. So here we've got sort of nasty looking three-parted spine, which was modified from a leaf. And we know that because we've got a bud right above it. And everything else, all of those epidermal extensions are just called prickles. And it doesn't matter if they're this size or they're this size, they're still technically called prickles. But of course, the important thing to remember here is that informally, you can use all of these terms interchangeably. So you'll see things called thorns, spines, prickles. People will refer to these as thorns, for obvious reasons. But in reality, they're just prickles. So I'm going to talk just briefly about reproductive characteristics of plants. And again, the reason for this is that we often will not see these. We try not to focus on this in the presentation, but there's going to be a few examples where we're going to have to know about some of these characteristics. So when you're looking at flowers, you want to think about, how are the flowers grouped? Is there a cluster of them? Are they solitary? You want to think about, obviously, their size and color, but also the symmetry of that flower. So when it comes to how flowers are grouped together, if you have a group of flowers more than solitary, they can be growing in a number of ways. And one of the most common things is to have what's called a raceme. So what this means is, as the plant is growing, it's producing flowers as it grows. So the older flowers, represented by these larger circles, are produced at the base. And as you go up, the flowers get younger and younger and younger, right? So here's an old flower down at the base of this Baptisia. And then as we go up, these are just in bud. So it's called a raceme, or it's called indeterminate, because it can just keep on growing. But you can also have a situation called a cyme, where the branch grows, it terminates in a flower, an older flower, and then it produces two younger flowers below it. And that is a determinate type of growth, because obviously that branch can't keep on growing. So it's called a cyme, or a determinate inflorescence. And you can recognize these usually because the flowers are kind of in threes. So you see that there's a little group of three. This is a compound cyme, but again, if you were to look at all the individual units, all of those flowers are just in little groups of three. There's an older flower and some younger flowers below it. Again, you want to think about the symmetry. Is it more or less looking like a star shape, where you can divide it into multiple planes and still have mirror images? It's called radially symmetrical or actinomorphic, star-shaped. Or is it bilaterally symmetrical? So pea flowers always are, or tend to be, at least one group of them, are always bilaterally symmetrical or zygomorphic. So you can only cut it in one plane to get mirror images. And just briefly, when you're looking at fruits on a plant, you want to think about, again, whether you've got some aggregate of fruits or are they single, whether or not the fruits are fleshy, whether they are opening up, or whether the entire fruit is dispersing as a unit, and any other modifications. Are the fruits winged? Do they have little projections? And sometimes you need to open up the fruit and see how many and how large the seeds are inside. So fleshy fruits, we tend to talk about mostly berries and drupes. So berries are fleshy fruits that have multiple seeds. Drupes are fleshy fruits that have a single seed with this bony endocarp, this little layer on the inside. So berries and drupes, the most important terms there. And then for dry fruits, you have fruits that sort of are single-seeded and disperse as a unit. So things like achenes, which are these small dry fruits, the entire thing drops off. So think about like a sunflower seed is an achene. And then we have kind of a larger version of that, which we call a nut. Acorns, obviously, where the whole fruit drops off and it's dry, it never opens up. And then we also have fruits that can open in a variety of ways, but the most important term here is capsule. So if it's a dry fruit that opens up to release its seeds, it's called a capsule. Other fruits might open up in or might break apart in various ways. And again, some of them may be winged. So you think about like maple trees have these really distinctive schizoid samaras, right? Where there are these two fruits that are developed each one has a wing, and then they break apart at maturity. So it's a schizocarp that's also winged on both of the individual fruits. So again, just a few things there, again, just to think about these various things that we need to look at on a plant, individual characteristics we want to be thinking about. So I'm over time a little bit by about 10 minutes. If there are any questions, I'd be happy to take them. Dexter, do we want to just go ahead and break for the 10 minutes and come back about 10:25?
Yeah, let's go ahead and take a 10-minute break and be back at 10:24, 10:25. Yeah.
Yeah, and if you have any questions for me in the meantime, just go ahead.